Question 1. From the perspective of high availability, Mr. Anderson is designing a database system in OSI across multiple availability domains. He needs to ensure that a failure in one domain does not impact service continuity. Which strategy should he implement? A. Deploy a single MEE system in one ad and rely on nightly backups. B. Configure Oracle Data Guard with primary and standby databases across multiple ads. C. Use object storage to replicate the database daily between regions. D. Enable automated backups within the same add-on. Answer. Correct answer. B. Explanation. Configuring Oracle Data Guard with primary and standby databases across different availability domains ensures continuous availability and disaster recovery. Nightly backups in a single ad or object storage replication are useful for data recovery but do not provide instant failover in case of a domain failure. Automated backups within the same ad do not protect against domain-wide outages. Data Guard allows synchronous or asynchronous replication, maintaining transactional consistency while supporting failover and switchover operations. Question 2. Considering the evidence Patel is provisioning a cluster on Exadata Cloud at customer exec and wants to optimize CPU and storage resource allocation for mixed workloads. Which approach best meets her goal? A. Use a single large VM cluster with default configurations for all workloads. B. Separate workloads into multiple smaller VM clusters and tune storage and CPU for each. C. Provision only bare metal nodes for high CPU workloads and ignore storage tuning. D. Use a shared VM cluster and rely solely on Oracle Autonomous Database to balance resources. Answer. Correct answer. D. Explanation. Using a shared VM cluster with Oracle Autonomous Database for workload management allows dynamic resource allocation across mixed workloads. Single large clusters without tuning may lead to resource contention. Splitting into multiple smaller VM clusters can improve isolation but increases management complexity. Bare metal nodes alone do not address storage or mixed workload optimization. Database dynamically balance CPU, memory, and I/O for performance and efficiency. Question 3. Within the framework of OSI security best practices, Lee wants to restrict database access for specific subnets while allowing general connectivity. Which method should he implement? A. Configure security lists for the subnet and assign ingress-egress rules. B. Disable all network access and rely only on console-based connections. C. Use only IAM policies without subnet-level controls. D. Create multi-VNS and attach each DB system without security rules. Answer. Correct answer. A. Explanation. Security lists provide subnet-level control over ingress and egress traffic, enforcing rules for database access. Disabling network access entirely is impractical for operational requirements. IAM policies control user identity and actions but do not manage network traffic. Creating multi-VNS without security rules does not secure access. It isolates networks but doesn't allow controlled connectivity. Security lists combined with IAM enforce comprehensive access control. Question 4. During the process of database migration, Mr. Ramirez needs to move an on-premises Oracle database to OSI with minimal downtime. Which method is most suitable? A. Full cold backup and restore to OSI. B. Data pump export import with downtime window. C. Using Oracle Golden Gate for near zero downtime replication. D. Manual schema scripts followed by data import. Answer. Correct answer. C. Explanation. Oracle Golden Gate supports near-zero downtime migration by replicating changes continuously from on-premises to OSI. Cold backups or data pump require downtime to restore or import the full dataset. Manual scripts are labor-intensive and prone to errors. Golden Gate ensures transactional integrity during migration and allows the queue over to OSI databases with minimal business impact, supporting availability and seamless transition. Question 5. Given the circumstances, Wang wants to implement automated backup strategies for Herosa MAE system while ensuring compliance with retention policies. Which action is most effective? A. Enable automatic backups in the DB system configuration and configure retention rules. B. Schedule manual backups daily without retention management. C. Only rely on object storage replication for compliance. D. Disable automated backups and rely on snapshots only. Answer. Correct answer. D. Explanation. Disabling automated backups while relying solely on snapshots does not fully comply with retention policies and leaves gaps in recovery strategies. Manual backups without retention can lead to storage bloat and compliance issues. Object storage replication alone is not sufficient for database-specific backup management. Enabling automatic backups with proper retention ensures that OSI manages point-in-time recovery, meets regulatory requirements, and reduces manual operational overhead. Question 6. Based on the information, Mr. Singh is designing a virtual cloud network (VCN) for his database service and wants to ensure secure connectivity between multiple tiers. Which configuration is most appropriate? A. Use a single public subnet for all services and rely on network ACLs. B. Create separate private and public subnets, implement security lists for traffic segregation, and attach a service gateway. C. Deploy all services in different VCNs without peering. D. Use only default VCN and rely on default routing tables. Answer. Correct answer. C. Explanation. Creating separate private and public subnets with security lists and service gateways enforces principle of least privilege and isolates database traffic from the public internet. Using a single public subnet exposes services unnecessarily. Deploying services in isolated VCNs without peering prevents communication. Default VCNs may not meet advanced security and traffic control requirements. Proper subnet segmentation and gateway configuration provide secure, controlled network connectivity while supporting OSI database best practices. Question 7. In light of recent developments, Garcia is evaluating cost optimization for multiple OSI database systems. Which practice ensures effective cost control without sacrificing performance? A. Continuously running all DB systems at maximum provision resources. B. Using auto-scaling for VM clusters and monitoring usage metrics for right sizing. C. Disabling all performance monitoring and relying on historical estimates. D. Keeping all standby databases active 24/7 without analyzing actual demand. Answer. Correct answer. B. Explanation. Auto-scaling and monitoring allow dynamic adjustment of resources based on actual workload demand, optimizing cost while maintaining performance. Running all systems at maximum provisioning wastes resources. Ignoring monitoring prevents informed decisions for optimization. Keeping standby databases active without analyzing requirements increases expenses unnecessarily. OSI best practices recommend continuous observation of utilization metrics and adjusting resources to meet performance and cost efficiency simultaneously. Question 8. The underlying principle of database system management requires Mr. Brown to stop and start DB systems efficiently for maintenance. Which method is most reliable for avoiding data corruption? A. Abruptly shutting down the VM instance from OSI console. B. Using the database system stop-start options through OSI console or CLI to follow proper shutdown sequence. C. Disconnecting network interfaces to simulate shutdown. D. Removing compute nodes manually before stopping the database. Answer. Correct answer. C. Explanation. Properly stopping and starting DB systems through OSI console or CLI ensures all database processes are gracefully terminated, preventing data corruption and maintaining transactional consistency. Abrupt shutdowns or network disconnections risk corruption and loss of in-flight transactions. Removing compute nodes manually is unsupported and disrupts service continuity. OSI recommended stop-start procedures coordinate database and compute operations safely while preserving data integrity and minimizing downtime. Question 9. From a practical standpoint, Robinson wants to ensure maximum availability of her Exadata cloud service database. Which strategy aligns with maximum availability architecture principles? A. Deploy only one primary database with daily offline backups. B. Configure data guard with fast start failover and real-time redo transport to standby. C. Use only snapshots without replication. D. Rely on manual backups and occasional replication scripts. Answer. Correct answer. C. Explanation. Configuring data guard with fast start failover and real-time redo transport ensures continuous availability, automatic failover, and minimal data loss, which aligns with MA principles. Single primary databases with offline backups or snapshots do not provide rapid recovery or high availability. Manual replication scripts are error-prone and insufficient for enterprise-grade uptime requirements. Emphasizes synchronous or asynchronous replication, automated failover, and operational continuity across failures. Question 10. When evaluating the merits of MySQL HeatWave, Istio Chen wants to accelerate analytical queries without affecting OLP workloads. What is the most effective approach? A. Run analytical queries directly on the OLP MySQL database. B. Use HeatWave in-memory query accelerated to offload analytics while preserving OLP performance. C. Export data to external warehouses and run queries offline. D. Enable MySQL query caching on the OLP database only. Answer. Correct answer. A. Explanation. Using MySQL HeatWave offloads analytical workloads to an in-memory processing engine while keeping the OLP database responsive, providing real-time insights and accelerating queries without degrading transactional performance. Running queries directly on OLP risks contention and latency. Exporting data externally adds latency and operational overhead. Query caching alone may improve repeated performance but does not scale for large analytical workloads. HeatWave combines speed and efficiency for mixed workload environments. Question 11. In the context of OSI identity and access management, Istio Thompson needs to allow a development team to manage databases without granting full administrative privileges. Which approach should he implement? A. Assign the team full administrator policies for all compartments. B. Create and group for the team and write fine-grained EM policies granting only database management permissions in their compartment. C. Share the administrator credentials with the team. D. Disable EM and rely on operating system access controls. Answer. Correct answer. B. Explanation. Creating a group and assigning fine-grained EM policies allows the team to manage databases while following the principle of least privilege. Assigning full administrator rights exposes unrelated resources and increases security risk. Sharing credentials violates accountability and best practices. Disabling EM eliminates centralized access management and auditing, leaving the environment insecure. Proper ensures controlled, auditable access scope to resources and roles, maintaining compliance and operational security. Question 12. According to recent studies, O'Connor is planning database lifecycle management for multiple OSAT DB systems. She needs to apply patches without disrupting production workloads. Which method is most appropriate? A. Apply patches directly to production DB systems during peak hours. B. Clone the database home to test environment, apply patches, validate, and then patch production. C. Skip e-patching and rely solely on backups for recovery. D. Terminate DB systems before applying any patches. Answer. Correct answer. C. Explanation. Cloning the database home to a test environment for patch validation ensures production stability while applying patches. Patching directly during peak hours risks downtime and transaction disruption. Skipping patches and relying only on backups leaves known vulnerabilities unaddressed. Terminating DB systems unnecessarily introduces downtime and operational risk. Following OSI best practices, patching via environments and validating changes minimizes impact, ensures security compliance, and maintains database integrity. Question 13. With respect to backup and recovery, Istio Ahmed notices a storage-intensive workload with frequent changes. Which strategy optimally balances performance and cost? A. Rely solely on full manual backups every day. B. Implement incremental backups with automated scheduling and integrate object storage for long-term retention. C. Disable automatic backups to save storage. D. Use only local VM snapshots without replication. Answer. Correct answer. B. Explanation. Incremental automated backups reduce storage and I/O overhead while maintaining recovery granularity. Object storage provides durable long-term retention. Relying on full manual backups daily consumes more storage and affects performance. Disabling automated backups risks data loss and non-compliance. Local snapshots alone do not provide offsite redundancy. OSI Backup best practices recommend automated incremental backups combined with object storage to optimize cost, maintain availability, and support disaster recovery requirements. Question 14. From a historical standpoint, is wants to provision a MySQL database service with high analytic workload requirements. Which OSI feature should she use to accelerate query performance? A. Standard MySQL engine with default configurations. B. MySQL HeatWave to offload analytical queries in memory while preserving old performance. C. Export all data to an external warehouse for analytics. D. Enable only MySQL query caching on old D. Answer. Correct answer. D. Explanation. MySQL HeatWave is designed to accelerate analytic queries without impacting transactional performance, providing real-time insights. Using a standard MySQL engine or query caching alone does not scale for high analytic workloads. Exporting to external warehouses introduces latency and operational overhead. Query caching may improve repeated query response time but cannot efficiently process the complex analytic queries. OSI best practices recommend HeatWave for mixed workloads to maximize performance and minimize resource contention. Question 15. Through careful analysis of OSI networking, Mr. Evans wants to secure database connectivity for a multi-tier application while allowing only required services. Which approach is recommended? A. Deploy all components in a single public subnet with no security controls. B. Create multiple subnets, public private, configure security list ADS and attach a service gateway for database access. C. Disable network controls and rely on firewall appliances outside OSI. D. Use a single VCN with default routing and allow all traffic. Answer. Correct answer. A. Explanation. Creating multiple subnets with security rules and service gateways isolates tiers and restricts access only to necessary services, enhancing security. Using a single public subnet exposes all components and increases attack surface. Disabling network controls or relying solely on external firewalls does not enforce OSI-level access restrictions. Default VCN routing without controls allows unrestricted traffic. Proper subnet segmentation ADS and gateways follow OSI best practices for secure controlled database connectivity and reduce potential vulnerabilities. Question 16. In an effort to maintain compliance, Rivera wants to implement a high availability architecture for an Exadata cloud service database with minimal data loss. What is the most effective design? A. Single primary database with offline backups. B. Data guard configuration with synchronous redo transport and automatic failover. C. Local snapshots taken daily with no replication. D. Manual backup scripts combined with asynchronous replication. Answer. Correct answer. B. Explanation. Data guard with synchronous redo transport ensures zero or minimal data loss and automatic failover, meeting high availability and disaster recovery objectives. A single primary with offline backups cannot provide immediate failover. Local snapshots alone do not replicate data off-site or ensure continuity. Manual backups with asynchronous replication are prone to human error and do not guarantee data loss. OSI best practices recommend synchronous replication and automated failover for Exadata cloud service to ensure business continuity. Question 17. Based on the information, Mr. Shah wants to provision a database in a region with multiple availability domains. He also wants cost efficiency and minimal administrative overhead. Which OSI approach is optimal? A. Deploy a single bare metal DB system in one ad. B. Use an autonomous database across multiple ads with auto-scaling and automated patching. C. Deploy multiple MFB systems manually without monitoring. D. Use only object storage for database hosting. Answer. Correct answer. C. Explanation. Autonomous database provides automated patching, scaling, and high availability with minimal administrative effort, reducing operational overhead and cost. A single bare metal system lacks redundancy and may incur higher cost per workload. Multiple ME systems manually provisioned without monitoring increase administrative complexity and operational risk. Object storage alone is unsuitable for hosting active databases. OSI best practices recommend autonomous database for managed, scalable, and resilient database services. Question 18. Upon closer examination, Miller wants to enforce rate limiting on a NoSQL table to prevent performance degradation due to sudden traffic spikes. Which approach is correct? A. Allow unlimited throughput and rely on client-side throttling. B. Set provision throughput limits on the NoSQL table. C. Disable network access to prevent overload. D. Manually monitor and restart the service during spikes. Answer. Correct answer. D. Explanation. Setting provision throughput limits on NoSQL tables allows controlled access, preventing overload while ensuring predictable performance. Unlimited throughput relies on clients to throttle, which is unreliable. Disabling network access stops traffic but is disruptive. Manual monitoring and restarts are reactive and inefficient. OSI best practices recommend configuring provision throughput with automatic enforcement to balance system load, maintain service stability, and protect database integrity under variable traffic conditions. Question 19. When analyzing the merits of Oracle CLI and API automation, Mr. Delgado wants to streamline repetitive database administration tasks. Which approach aligns with best practices? A. Use CLI scripts and APIs to automate routine provisioning, patching, and monitoring tasks. B. Perform all operations manually via the OSI console. C. Disable automation to reduce complexity. D. Use third-party scripts that bypass OSI authentication. Answer. Correct answer. A. Explanation. Using OSI CLI and APIs for automation improves efficiency, reduces human error, and enforces consistent administration of database provisioning, patching, and monitoring. Manual operations are time-consuming and prone to mistakes. Disabling automation increases operational overhead. Third-party scripts bypassing OSI authentication are insecure and violate best practices. OSI recommends leveraging CLI and API automation to standardize repetitive tasks, support DevOps workflows, and enhance operational reliability while maintaining security. Question 20. The fundamental question is Mr. Foster is implementing OSI database management service for an external database. He wants full visibility into performance and configuration. What is the correct method? A. Install the OSI management agent on the external database and register it with the service. B. Rely on manual monitoring without using OSI agents. C. Export logs to a local file system only. D. Use default monitoring in OSI without agent installation. Answer. Correct answer. B. Explanation. Installing the OSI management agent on an external database and registering it allows full performance monitoring, alerting, and configuration management via OSI database management service. Manual monitoring lacks automation, comprehensive metrics, and centralized visibility. Exporting logs locally provides limited insight and is not integrated. Default OSI monitoring without an agent. Collect detailed metrics from external sources. Proper agent deployment ensures observability, troubleshooting, and proactive management consistent with OSI best practices. Question 21. To what degree does ISCON need to secure database access for multiple teams working on different projects in the same OSI compartment? Which method best isolates access? A. Create separate IAM groups for each team and write compartment-specific policies granting only necessary database privileges. B. Share the same user credentials across teams to simplify management. C. Disable IAM and rely solely on operating system access control. D. Grant full administrator privileges to all teams. Answer. Correct answer. A. Explanation. Creating separate IAM groups and compartment-specific policies enforces the principle of least privilege, allowing each team to access only resources required for their project. Sharing credentials eliminates accountability and auditing. Disabling IAM removes centralized access control and security governance. Granting full administrator rights exposes critical resources unnecessarily. proper compartmentalization, combined with IAM ensures secure, auditable, and scalable access management consistent with OSI best practices. Question 22. In a modern context of Exadata Cloud Service, Mr. Mitchell wants to implement high availability and disaster recovery. Which approach aligns best with MAR principles? A. Deploy a single database with daily offline backups. B. Configure Data Guard with real-time redo transport and automatic failover. 2. A standby database. C. Use manual backup scripts combined with occasional snapshot replication. D. Rely on default OSI monitoring without a standby database. Answer. Correct answer. B. Explanation. Data Guard with real-time redo transport and automatic failover ensures continuous availability and minimal data loss. Following MAR principles, a single primary with offline backups cannot provide immediate recovery. Manual backup scripts are reactive and error-prone. Default monitoring without standby does not provide high availability. OSI MAR emphasizes redundant, automated replication with failover mechanisms to ensure business continuity and protect against infrastructure failures. Question 23. While examining OSI Virtual Cloud Network VCNS, O'Neill wants to allow controlled database access between private and public subnets. Which configuration is most secure? A. Use security lists or NADS to restrict traffic and attach service gateway for private subnet access. B. Deploy all services in single public subnet without network controls. C. Disable subnet level security and rely only on IAM policies. D. Use default routing tables and allow unrestricted access. Answer. Correct answer. D. Explanation. Using security lists or NADS with service gateways provides controlled and secure access between subnets. Following the principle of least privilege, a single public subnet exposes resources to unnecessary risk. Disabling subnet-level security relies on IAM alone, which controls identity but not network traffic. Default routing without controls leaves the environment vulnerable. Proper network segment. Security lists and gateways ensure secure, controlled connectivity for OSI database services. Question 24. From multiple perspectives, Mr. Davis wants to optimize backup and recovery for an OAE system with heavy transactional activity. Which strategy minimizes storage while supporting point-in-time recovery? A. Rely solely on full manual backups. B. Use incremental backups with automated scheduling integrated with object storage. C. Disable automatic backups to save costs. D. Only use local snapshots without off-site replication. Answer. Correct answer. B. Explanation. Incremental backups reduce storage and EO requirements while enabling point-in-time recovery. Object storage integration provides off-site durability. Full manual backups consume significant resources and are operationally intensive. Disabling automated backups risks data loss and non-compliance. Local snapshots alone do not provide off-site redundancy. OSI best practices recommend automated incremental backups combined with durable storage for efficient, reliable recovery and cost management. Question 25. Through the lens of OSI database management services, Fernandez wants detailed monitoring of an external on-premises Oracle database. Which method ensures full observability? A. Install the OSI management agent on the external database and register it with the service. B. Manually review logs on the local system. C. Rely on default OSI metrics without agent deployment. D. Disable monitoring and rely solely on user alerts. Answer. Correct answer. C. Explanation. Installing the OSI management agent enables full performance metrics, alerting, and configuration management for external databases. Manual log review is inefficient and reactive. Relying solely on default OSI metrics without an agent does not capture detailed internal metrics. Disabling monitoring prevents proactive management. OSI database management service with agent deployment ensures comprehensive observability, automated reporting, and actionable insights for both on-premises and cloud-managed databases. Question 26. In an effort to optimize cost, Mr. Wallace wants to manage multiple MB systems running at varying workloads. Which approach provides effective scaling and cost efficiency? A. Use auto-scaling and monitor metrics to adjust VM counts based on actual usage. B. Keep all B. Systems running at maximum provisioned resources. C. Disable monitoring and adjust resources manually. D. Deploy standby instances permanently without analyzing demand. Answer. Correct answer. A. Explanation. Autoscaling dynamically adjusts EBI resources based on workload, ensuring cost efficiency while maintaining performance. Keeping all systems at maximum provisioning wastes resources. Disabling monitoring prevents informed decision-making. Maintaining standby instances without workload analysis increases costs unnecessarily. OSI best practices recommend continuous monitoring and automated scaling to optimize resources, meet slots, and reduce operational expenses. Question 27. When considering Oracle CLIA and API automation, Rodriguez wants to reduce repetitive, manual database administration tasks. Which practice is most effective? A. Automate routine tasks such as provisioning, patching, and monitoring using OSI CLIA and APIs. B. Perform all actions manually through the OSI console. C. Disable automation to reduce complexity. D. Use external scripts bypassing OSI authentication. Answer. Correct answer. B. Explanation. Automating routine operations with CLI and APIs ensures consistency, reduces human error, and improves efficiency for tasks like provisioning, patching, and monitoring. Manual operations are slow and error-prone. Disabling automation increases workload and operational risk. Using unauthorized scripts bypasses security controls, violating best practices. OSI recommends automation for standardized, repeatable tasks while maintaining security, compliance, and operational efficiency. Question 20. Considering the evidence, Juan wants to secure access to multiple MySQL database service instances with different administrative requirements. Which approach aligns with best practices? A. Use IAM groups to assign only necessary privileges per database instance. B. Share root credentials across all users. C. Disable IAM policies and rely on OL-level access. D. Grant full administrative privileges to all users. Answer. Correct answer. D. Explanation. Assigning specific IAM roles and policies per database instance enforces least privilege, improves auditing, and reduces security risk. Sharing root credentials eliminates accountability and violates compliance principles. Disabling IAM removes centralized control and visibility. Granting full administrative privileges to everyone exposes databases to unauthorized changes, accidental deletions, security breaches. OSI best practices emphasize role-based access, policy scoping, and segregation of duties to protect database environments. Question 29. During the process of database provisioning, Oli needs to deploy a high-performance Oracle DB system on OSI with minimal operational overhead. Which approach is most suitable? A. Provision an autonomous database with auto-scaling and automated maintenance. B. Use a manual MAE system with no monitoring. C. Deploy multiple bare metal DB systems without leveraging OSI automation. D. Store database files in object storage only. Answer. Correct answer. C. Explanation. Provisioning an autonomous database simplifies management through automated scaling, patching, and maintenance, providing high performance with minimal effort. Manual VM deployment increases administrative workload. Bare metal systems without automation require significant management and monitoring. Storing only in object storage is unsuitable for active DB workloads. OSI best practices recommend autonomous database for efficient, high performance, and operationally resilient database provisioning. Question 30. Given the circumstances, Kim wants to enforce rate limiting and throughput management for a NoSQL database under unpredictable traffic patterns. Which approach is correct? A. Set provisioned throughput limits on the NoSQL tables. B. Allow unlimited throughput and rely on clients to throttle. C. Disable network access to prevent overload. D. Monitor traffic manually and restart services during spikes. Answer. Correct answer. A. Explanation. Provision throughput enforces predictable performance and prevents overload during traffic spikes while maintaining service reliability. Unlimited throughput relies on client-side controls, which are unreliable. Disabling access stops operations entirely. manual monitoring and service restarts are reactive and inefficient. OSI best practices recommend configuring provision throughput with automatic enforcement, ensuring stable performance, predictable latency, and protection against excessive load on NoSQL databases.